So why can't we calculate the body mass index with those entered values? For two main reasons. For one, weight input and height input are string values. And to calculate our body mass index, we definitely want numbers. To be specific, we want float values, since both weight and height, of course, could contain decimal places, and the final body mass index number definitely also will have decimal places. So we'll need to convert our strings to floats first. But in addition, we also have a more subtle gotcha here, which can be hard to spot. If I run my module again, and I quickly enter my values again, we see the output here. But there's one thing that actually is strange about these two values that are output here at the bottom. Each value sits in a new line, but here we actually are using print, not println, for outputting weight input and height input. So actually, both should be in the same line because print does not add any line break after printing the value which we want to output. And yet here we are with a line break between the two values. The reason for that is that actually the value which we read here includes the line break entered by the user by hitting the Enter key. And this might be unexpected, but if you press the Enter key, that is actually also some input which is read and stored in weight input and height input. It's represented as this special character, this special byte internally. And that's part of the overall input string that we read here. So therefore, we have to remove that line break as a first step to then make sure that we only have the numbers stored in that string and not that extra line break. Because then we'll be able to convert those numbers into real numbers, into float numbers in a second step. If a line break is included in addition to the numbers, that conversion can be a bit more tricky since a line break can't easily be converted to a number. And therefore, also to show you how you can get rid of such an unwanted character, no matter if it's a line break or any other character, we'll do that as a next step. Remove the line break from the user input. And I'll do that here. I'll get rid of these two print statements, and instead here I now want to clean the inputs. And I want to overwrite weight input. So I want to overwrite this variable, which we create here, with a new value, and the new value should actually be the old value minus that line break. Now, what we can't do is weight input minus the line break or anything like that. These kind of operations don't exist and don't work. Instead, we can use another package built into Go, and that would be the strings package here at the very bottom. If I hit enter, it's added to imports. And this strings package gives us utility functionalities that help us transform and work with strings. And for example, it has a replace command which we can execute, which will replace a string inside of a string with another string. So here we first of all then provide the string through which we want to search. So weight input in my case here. That's the string into which we want to look. Then we add a comma here and specify the value we want to look for. Now not as a byte or rune, but as a string with double quotes. It's still this special character though. Then as a third value, we specify the character with which we want to replace this character we're looking for. And that should be an empty string, so we want to get rid of it, and that's how we can delete it, by replacing a line break with nothing. And then as a last step, we just have to specify how often we want to make that replacement. And if we enter -1 here, we're saying make it for all the line breaks you find, but of course we should only find one. And that will now replace the line break with nothing. It will remove it. And hence I'll copy that and do the same for height input, height input. and use that here inside of the replace command as well. And with that, we now ensure that there we also strip the line break. And now with that, if we would again output this with print, if we output weight input and then also height input here, and we then run this module again, we would now see that if I enter my two values, now actually they are output in the same line without any white space or line break in between, as it should be the case for print, because print does not add any line break or white space. So now that works, but weight input and height input are still strings. And as I mentioned, in order to use them in a calculation, in a mathematical calculation, we should convert them to numbers. Now, for that, we could now add a new variable, weight, and try to convert weight input into a number, into a float, for example, by using that float64 command we saw before in the course, and passing weight input to it. But as you can see, this doesn't seem to work. We get an error that we can't convert weight input to float64 like that. The reason for this is that these conversion functions, float64, string, and int, are fairly trivial. And if we want to convert a string, the problem is, as mentioned in the previous section already, that a string could be something like this, which theoretically would be easy to transform to a number, but it could also be something like this, which would be impossible to transform to a number. And float64, int, and so on simply don't have the built-in capabilities to handle these impossible cases. But nonetheless, Go has got us covered. It has specific string to number conversion commands which are available in another package that we can add. And that's the strconf package, which stands for string conversion. Again, I start typing and hit tab to autocomplete this, and that also adds the strconf package import. And as you can tell, at this point we are already using quite a lot of packages here, and that's not uncommon. In most programs which you are going to write, you will use various functionalities from various packages so that you don't have to reinvent the wheel for all the logic on your own, but instead you can build up on these fundamental building blocks provided by the language itself or provided by other third-party developers. So with that, we added the this package import, and now here we can execute the parse float command on this strconf package. And that does what the name implies. It tries to parse a float from some string. And here we can now provide weight input. Now, just as read string, the parse float command also returns two values, not just one. And hence here again, I'll add a comma after weight, and again add this underscore to signal that again, I'm not interested in the second value, because we'll explore these second values and how we can deal with multiple values in later course sections. For the moment, it's fine if we do it like this. Now, parse float actually also wants a second value that we pass to it though, and therefore we should add a comma. And the second value simply should signal which kind of float we want to create, 32 bits or 64 bits. And here I'll go for 64, and hence we enter 64 as a second value here. Alternatively, you could enter 32, but I'll go for 64 as I just mentioned. Now that will give us the weight variable, which now will be of type float64, as you can tell. As a matter of fact, if you use 32 here, this actually still will technically be of type float64, but the float will be parsed with less precision. Can be a bit confusing, but that is how it works internally. Here, however, I'll parse it with high precision, even though technically for these kind of inputs, we of course don't really need to do that. Now that's the weight. I'll now copy that to do the same for the height. And here get my height variable by parsing the height input like this. And now we got weight and height as floats, and therefore now finally we can calculate the body mass index with that formula. Now to calculate the body mass index with that formula, I'll add a new variable. BMI sounds like a fitting name. And I'll then create it and initialize it in one go with that shortcut, which we used before as well. And here the formula simply is weight divided by height times height, though we want to make sure that height times height executes first, and in Go, like in regular math, you can also group operations together by adding parentheses. So now this here will be executed first, and then weight will be divided by the result of this operation. And we are dealing with floats only here on the right side of the colon equal sign operator, and therefore BMI is also correctly inferred to be of type float64 itself. And therefore now at this point we will have that BMI calculated. Now as our last step we can output that. So here below that comment I now want to output the BMI, and for this I'll use the printf command here to have more control over how the BMI is formatted, because here I want to say your BMI colon and then output the BMI, which is a float with only 2 decimal places. So I don't want to output a super long number with tons of decimal places, but I want to just show the first 2 decimal places. And we learned how that works. We can use the %sign .2f placeholder to output the value of a float with only the first 2 decimal places showing up. And then here we just have to add a comma and then tell Go which variable contains the value which we want to use here, and that's of course the BMI variable in this case. And with that, if we save this all should be done, this application should be finished. And hence, if we now open the terminal and we run this program, we can again enter our data in kilograms and meters, and we get the BMI result here. Now, it is worth mentioning that, of course, this application does not have any checks that ensure that we get correct user input. For example, if I run this again and I enter max here and high, it of course just gives me this strange output, NaN, which stands for not a number, because it fails to parse those inputs to floats correctly, and therefore it fails to calculate the BMI. We have no protection against that in this program because we haven't learned about the tools we would need for that at this point. But that's not too bad. These are all concepts we are going to learn throughout the course. For the moment, we are using the things we learned about. Specifically, we are working with variables, values, different types of values, input and output, and also various packages. But speaking of that, let's now explore how we can manage our program here if we split our code across multiple files and also multiple packages. And let's also revisit this concept of having constant values.